Washington State University. Go Cougs!
Hello and welcome back to our course on collecting smartphone sensor data using iOS. We are in Module 3 where we are learning how to communicate the sensor data from the device. And in Part 3 of this module, we'll actually be sending the sensor data over the web to a web server. In iOS, the main way of doing communication over the web is to use the URLSession class. And to use that class is basically a three-step process. First, we create a data task, and that data task consists of a URL request and a completion handler. The URL request is something that we will build that will contain our sensor data, and it will be a post request. And then when we execute the data task, it will make that URL request. Then the completion handler is a function that's called when the communication is complete, and it then passes in information about whether an error occurred or whether the communication was successful. So once we create that data task, the next step is to execute it, and to do that we call the resume method of that data task. And again, that will initiate the communication, and when the response comes back, it will call the completion handler. And then in the third step, we will handle the various possible responses that could come back from the communication. So let's first look at how we create and start up this communication. Here we are redefining our send data function that right now is just a simple function that prints out our JSON string. But in this version, we still want to grab the current sensor data and the current timestamp and convert all that to a JSON object. But in order to send it as data over the web, we need to convert it to raw data, not to the ASCII text that it resides as in the string form. So a string has a method called data, and then you tell it what type of data you want to use. So in this case, we're going to use an 8-bit byte for each character, and that's going to use this UTF-8 format, which is a common format for strings sent over the web. So now that we have our raw JSON data, we want to build our URL request. So we start out with the actual URL that we create from a string. In this case, we're going to be calling a PHP script called store data, and we will pass in this JSON data into that script, and it will unpack that JSON data and store it in a file on the server. We then create a URL request based on that URL, and we set a few properties of that request. First, we designate it as a post request. The default would be a GET request, but we want to use a post request. And then the body of the request will be our JSON data. And lastly, because this is JSON data and not just text data, we need to specifically tell the server that JSON data is coming. And the way you do that is you set one of the HTTP header fields, namely the content type, to application/JSON. So that will tell the server that it's about to receive JSON data as opposed to the default text data. So that's sufficient to build our URL request. And now we build the task, which is a URLSession task. And we pass in, to create that data task, we pass in our request, and then we pass in the function that should be called when the request is done and returns. So we'll be defining this handle request function in just a second. So lastly, in order to actually initiate this communication, we call the resume method of this new data task that we just formed. So that is how we send the data over the web using the URLSession class of iOS. Now, before we copy this into our app, let's go ahead and look at this handle response function. So there's a lot to this handle response function, basically because there are several possible responses we could get from this communication task, and we need to handle them all gracefully. As you can see, the handle response function takes 3 arguments. One is the data, which is the data returned from the server. The second is the URL response, which is specific HTTP status codes and other response information about whether the communication was successful. And lastly, an error is passed in, which is another level of possible things that could go wrong, not with the web server responding inappropriately, but perhaps not even be able to contact the web server. So first, ultimately, as you see down here, we're going to be setting our message label in the view of the app to convey to the user whether this communication was successful. So we'll start out setting that message to just that an error has occurred. But as you can see, eventually, if we make it through all of these tests, we'll eventually set that message to data sent. So the first test, we'll check and see if an error even exists. So remember, this is an optional, so it's either going to be nil or an actual error. And this optional chaining conditional will set error to the actual error if it exists. But if the error is nil, then this condition will be false and we'll go to the else part. So if the error in fact does exist, then we will simply print it out to the console and of course eventually convey the message to the user that an error has occurred. If there is no error, then the next step is to check the response from the server to see if that's appropriate. So in order to do that, we have to actually cast the response to a different type, and that is to the HTTP URL response. So we cast it to that type, and then we can access the status code, which is one of the properties of the HTTP URL response. And if everything went well, that status code should be 200. That's the standard for an HTTP response that was successful. If it's not 200, then something went wrong, and we want to again print out that status code in the console so we can see why it happened. And of course, again, the user will be given this error message on the view of the app. But if the status code is in fact 200 and all is well, then the last thing we want to do is access the data that was returned from our PHP script. And as we'll see later, if all goes well, the PHP script will simply return the string success. And so we take the data that was passed into this handle response and we convert it to a string, again using this UTF-8 format. And then we check and see if that string is equal to the word success. If it is, then in fact everything went well. We set the message to data sent, and then down here that message will actually be conveyed to the user. So this last piece down here, as we've been saying, is basically to set the view appropriately based on how this communication went. So we're going to set the message label text to the message, and then we'll re-enable the send button on the view. But you'll notice that this is wrapped in a rather cryptic construct here called a dispatch queue. And you may remember back when we were handling the motion sensor data that we made sure that that motion data handler was run on the main queue. And in fact, whenever you make a change to the view, that has to occur on the main queue or the main thread. However, for this handle response, remember this handle response is called possibly on a different thread. So once the communication returns, it's going to call this handle response, but there's no guarantee that that process is going to happen on the main thread or the main queue. So if we were to leave this out and just try to modify these view elements directly, we would actually get an error message that would say that you're potentially modifying the view from some thread that's not the main thread. And if you actually tried to do that, of course, nothing will happen to the view because the other threads don't know what the message label and the send button, where they are. So all that being said, this construct here basically says that any of the commands that are in the scope of this dispatch queue are going to be executed on the main queue. And they're going to be executed asynchronously, which means that these commands will be sent to the main queue, and as soon as all of the other commands before it are done, these will be processed. But that all happens very fast, and so these updates will happen almost immediately on the view. So that's why we wrap it in this dispatch queue, to make sure that these updates to the view are made on the main thread. Okay, so let's go ahead and copy this code into our app, these two functions. So first I'll get out of the presentation and grab a copy of the send data function, go into Xcode, and so here's where we added in the preliminary functions for communication, getting the timestamp, and converting the data to JSON format. So I'm going to copy this new sensor data or send data function down here. And then, of course, we already have one up here, which was just printing out the JSON object to our console. So I'm going to get rid of this one so that we can use the new one that we just entered. And so now whenever the user taps the send button, it'll be calling this send data function. Okay, and back to the presentation, I will get the handle response function and copy that in. So we'll put that right below our send data function. Okay, so now everything is in place, at least on the app side, to communicate the sensor data and handle the response. But of course, the one thing we need to do is to actually make sure that this PHP script is in place on our web server. So first, let's take a look at that PHP script, and then we'll go over to a web server that I have access to, and we'll install it there. So back to the presentation. So here is the actual PHP script that we'll be accessing. So let's take a look at that. So the first thing that this PHP script does is it grabs the data that's sent via the post request. And the way that's handled is all of that data is kind of viewed as a file, and that file is called php://input. So what we're going to do is grab the contents of that file using this PHP function and store it in a variable called JSON data. But at this point it's still raw data, but it is valid JSON, a JSON object, so we can use this PHP function called JSON decode to convert that JSON data into a data structure in PHP that we can then access the actual data. And that's the purpose of the second argument, which is set to true, which is telling JSON decode to not only decode the data, but to put it into an associative array. So this basically means that we can do things like access the timestamp element of this dictionary, and it will return the actual timestamp. We could do the same for, say, latitude. We could say, what is the latitude entry of this dictionary, and it'll give us the actual latitude value. But instead of having to go through all of the individual sensor names, we are going to just loop through or iterate over this dictionary. And as we do, we're going to set the variable key to the key value, like timestamp, latitude, longitude, and value will be set to the actual value of those keys. Then we will construct a string from this information, which basically says something like latitude equals 1.234. And so it's just creating a string that we're then going to write to a file, and then we add a new line at the end in order to keep the file looking fairly readable. So this next line then is to put the contents into a file, and this file we're going to use is called sensor data. So that's going to collect all of our sensor data. We'll write this line we just created to it, and we'll do it in append mode, meaning that it will add to the file instead of overwriting what's there. And lastly, we'll put one more new line in there just to separate the individual collections of sensor data by a blank line. Finally, as we noted before, the value that's returned from the script is going to be this string success. And so we'll print that at the end, and that'll be what's returned as data to the handle response function back in the app. Okay, so you might, one way to get this script into our web server is to copy and paste it. But a word of caution here, if I were to copy and paste this code from PowerPoint into my Linux server, it's going to put in some extra new line characters, which will actually generate errors when we try to execute this PHP script. So I've actually typed in this PHP script by hand already in the file, as we'll see. One other point I should make is to be careful not to put an extra line after this last line of the script. So this question mark greater than sign should be the absolute last line of the script. If we were to put an extra line in there, then that would also be returned. And so we'd get success plus a blank line as the return data. And of course that won't match the string's just success, and it will say that the data wasn't sent when in fact it was. So be sure not to have any more lines after this last line of the script. Okay, so let's go over to the web server. So I have a terminal window opened up here to the web server, and just to let you know, the name of this web server is serc.wsu.edu, and this is an actual web server. It's actually used for our Smart Environments Research Center, which is what CERC stands for. But since I have access to that server, I'm going to use that to put our store data app there and our sensor data file that will store the actual sensor data. So I'm here in the HTML directory. Let me show you what's in there. So this is the CERC website, but the one thing that I added here was this web apps directory. So I just created that. And so I'm going to go into that directory. And here you can see that I have the store data PHP script already there. So when I edit that, I see the same script that we had in the notes. But again, if you just copy and paste it into a file, you'll get some extra line feeds that will generate errors when you try to run it. Okay, so our script is in place. The one other thing I need to do is to make sure that we can write to the sensor data file. So one way you can create a file is using the Unix touch command, so I'm going to do that. And I'm going to do a long listing of these files. The point being that when a web server runs a PHP script like store data, it's not going to be run according to the user that owns this file, in this case me, holder. It will be run by a user that's designated by the web server itself. So this is a Linux system and it's running the Apache web server. So the user that actually runs this store data script is called Apache. And so since holder currently owns this sensor data file, if Apache tries to write to it, it'll generate an error. So one way to fix this is to allow anyone to write to the sensor data file. And the way I can do that is I can use the change mod command and basically say that this a plus w designator says that all people can write to this file. So I'll make that change, and now you'll see the this RW for the user, the group, which is CASAS users, and everybody. So at this point, everybody can write to this file. Okay, so that's all we need on this side. Now let's go back to the app and get it ready to try this out. There's one more change that I need to make, and that is in the notes I've been using this generic example.com as our website that we'll be using. But as you just saw, the actual website we're going to use is this circ.wsu.edu. So I need to change that. But that should be the last change I need to make. And so now we should be ready to run our app and see if it, in fact, writes some data to our file. So I'll start up the app. And right now we're running in the simulator. So you might remember that the simulator will not provide any motion data to us. So those won't be available, but we will get the simulated location updates. So I'll start up the sensors, and we see the location is updating. And now let's send a snapshot of that data to the web server. So I'll hit send, and you might have seen that it briefly said sending data and then eventually data sent. So that basically means that we were successful. So now if I go back over to the web server and I look at the sensor data file, sure enough, I see that the sensor data was in fact added to that file. And again, the motion data isn't there, but the location data is. So everything seems to be working, but just to be sure, I'm going to run this on an actual device on the phone, so we will get the motion updates, and we'll also make sure that this communication works using an actual device. So I will stop that and stop the app on the simulator. Now I'm going to use my phone and connect it to my machine. And eventually it should show up. So there it is at the top. So I'll choose that as the target and we'll run it. Okay, so there we have the sensor app up and running. You can see that. So I'm going to start the sensors, and so now we are getting the actual motion updates there. So I'm going to go ahead and hit the send button, and again it said sending data and then eventually data sent. I'm going to send one more just for fun here. So I sent it again, it says data sent, so everything seems to be working. So now let's go back to the web server and check that sensor data file. Now we should have 2 more entries in there. And sure enough, well, we do. So there's our second 2 entries that we just sent from the phone. So that basically completes the sensor app, and we are getting successful communication and storing the data on our web server. Obviously, you may want to store the data in an actual database like MySQL, and you can look up lots of sources on the web for how to set that up, but it's a little beyond the scope of this course, so we're just writing it to a file. Okay, so let's jump back into the notes. So at this point, just to review what we've done in the course, so you've learned about iOS and Xcode and the Swift language. You learned about the types of sensors available on iOS devices, and then you learned about the core motion and core location frameworks, which is the main frameworks for accessing the sensor information. And then you learned about how to communicate over the web, and specifically how to send the sensor data from the iOS device to a web server. And you also completed the sensor app to implement all that we've learned. So that completes Module 3. Congratulations. And you now have the tools necessary to access sensor data on an iOS device and to communicate it to a server. So the next step, of course, is to analyze that data on the server, but we'll save that for another course on using statistical inference and machine learning to learn and make predictions about the data that we've stored. So thank you for completing the course, and we'll see you in another course.